and welcome to Inside Edition to discuss national, regional and international issues in depth. In today's episode, we will be speaking about the Kingdom of Bahrain's aerospace ambitions and the plan to launch Bahrain's first satellite into orbit in the next 2 years. The National Space Science Agency is setting up a space team with the aim of optimizing the use of space sciences within 5 years to serve national development and keep abreast of global strides. For more on this matter, we will be joined by Dr. Mohammed Al-Uthman, the board member of National Space Science Agency. But first, this for more.
5, 4, 3, 2, 1, ignition.
Okay, Houston, as I stand out here in the wonders of the unknown at Hadley, I try to realize there's a fundamental truth to our nature. Man must explore.
Welcome back. With us in the studios, Dr. Mohammed Al-Uthman. Thank you very much for joining us today. Dr. Mohammed, the fact that a space team is being made is a very big deal. When did this interest in astronomy and space science start in Bahrain?
Well, thank you for having me. It's my pleasure to be here and to clarify lots of things about this new topic. Yeah. Talking in general in astronomy, I think it started with the beginning of the human race. Yeah. Anybody who looks up in the sky will see the stars, try to make sense out of it, and that's when astronomy started. Yes. In Bahrain, I think it's the same thing. Yeah. Specifically talking about astronomy in more like a science. We started that in the University of Bahrain. We got several courses in astronomy, and then we have a minor in astronomy as an academic discipline. For the Bahrain Space Agency, it was established by royal decree in 2014, and since that we started working on getting Bahrain on the track for getting a space sector. And the big thing happened this year. Yes. Yeah, with the development of the Bahrain space team and the development of a wider vision to establish that sector here in Bahrain.
Beautiful. The agency is going to announce a strategic plan for 2019-2023, soon along with the general space policy. What can you tell us about the pillars of this plan? What makes it up and how the agency is benefiting from the global expertise in this field, also from the regional expertise in this field?
Yeah, the big and main goal for us at this moment is building human capacity, is getting Bahraini people, getting them an adequate training, adequate knowledge, adequate experience in the space sector. Space sector, building a spacecraft, a satellite is just part of that. Yeah. But how to build it, why you design something like that, maybe we'll go in details a little bit, and how to operate the satellite. And then you'll get the data from satellite, what to do with the data, with the satellite data. Exactly. That's a big thing. Yeah, and that's what we are trying to do. This is the first step, getting people how to build satellite. This is the first step, and several steps are coming.
Yes. Now, we've seen basically there has been some kind of a campaign where people are asked to basically apply to the program. As you said, the first plan is basically to discipline them or basically train people in how to build a spacecraft. What is the next step? What's the plan that's coming ahead?
Building the spacecraft. The next, first of all, building a spacecraft, the thing that we are going to build is what we call a CubeSat. Okay. It's a very simple satellite. It's a very simple system. Very simple talking in space terms. Yes, okay? Yes. System. We are not trying to get some real product out of that. Yeah. The real product is the human being. Yeah. This is what we are trying to get. So the thing that the payload or whatever we're going to get from the satellite is being done all over. But this is the first time for us. Massive. Okay. The next step satellite-wise, is building something we call like a micro-satellite. This is going to be slightly larger satellite with something that will really benefit from that, from this whatever data we're going to get from the second satellite. That is the basic goal that we are looking at.
Yes, beautiful. Now, part of the whole plan of training people is not just training the people that are working on the ships themselves that are going to go up, but also the staff that are on the ground that will be looking and deciphering the information or whatever comes. So, what can you tell us about the global cooperation that you have for the space team?
It's like common sense with anything. You don't start from zero. It will be a stupid thing to start from zero. So basically, we are starting from somewhere that we can start with our resources, with our capabilities, and with our requirements.
Yeah.
We have a very strong cooperation with our brothers in the Kingdom of Saudi Arabia and our brothers in the United Arab Emirates, and we are working on cooperation agreements, memo of understanding with other international entities, space agencies, like the UK Space, the Russian agency, Roscosmos, the Indians, and the Chinese.
Yes, beautiful. That's amazing. How can the National Space Science Agency's project serve the goal of comprehensive development of the Economic Vision 2030 in the Kingdom specifically?
Yeah, this is the thing now. What we are trying to do is build the experience that people that for sustainable development. For instance, for a CubeSat.
Yes.
If anybody would go and search for a CubeSat on the net, you'll see lots of school building them, lots of universities, lots of countries even starting their space project with CubeSat. The thing that we want is not like a kit you can buy, because some of those they do exactly this thing. To get into space, they just buy a kit, they put it together. That will take about 2, 3, 6 months, a year maximum, putting it together and then getting a launch opportunity and sending the CubeSat.
Yeah.
This is not what we are looking for. We are looking for the getting the experience for the Bahraini people.
Yes.
When you design something for the kit, you will get something, but this A and B, and then connect this C, and make sure that you have this reading, and so on. What we are really trying to do is, why do you use this part A, and why do you use this part B? If you change this part C to part D, what other things is going to change?
All right.
So the background we are looking for is more of a technical background.
Yeah.
You must be an engineering background, scientific background. So we're looking for people working in with the engineering background, fresh graduates, or slightly the age bracket we had from 20 to 35. Engineering, electronic, electrical, civil, mechanical, and so on. IT people. Lots of programming goes into the building the satellite and working with the data.
Yes.
So these experiences, these skills that we are really looking for.
Yeah.
Not just building the satellite. No, but why do you build this satellite, and why do you use component A, not component B?
Understood.
Component C, not component D. If you change this thing, what will happen? You have to work about for instance, the power consumption. They have to know how much, for instance, the solar panels, what's the area of the solar panels required for the given payload.
Yes.
How much batteries do you want to use? How much charge do you want to store? The size of the satellite will also change lots of the mechanical part. On the data you get, how much data you need to uplink and how much data you need to downlink.
Yes.
For instance, if you have an imager on the spacecraft, for instance, using the UHF, VHF, like the old antennas we had, is not enough.
Yeah.
You have to use something with a higher rate.
Yes.
And that's why we're going to use, for our CubeSat, we are planning to have, this is the plan, it's not finalized, to have a camera, for instance. This is dealing with lots of skills. One of them, for instance, communication, is using the S-band.
Yes.
The S-band is those old dishes, black dishes we used to have in the direct satellite broadcasting.
Yes.
Maybe then we'll go much higher using the KU and KA band, or those small digital satellites.
All right.
Dishes, yeah. These are the skills that we are looking for.
And that's basically what you guys are planning. That's why it's still a progress mission.
Yeah.
And the thing that is very important to mention at this point, that Bahrain has the manpower, they have the students, and they have the people, the engineers that you're talking about, the crafts that you are looking for. Is that right?
Definitely, and we are not just. This is the background we need. The actual things, the actual science, the actual skill, they will acquire that. Yeah. So we need be open-minded people, people that can learn new things. Okay, there is no space programs here in Bahrain. Yeah. So none of the candidates will have the adequate what we really need, and that's for the training part. For the first 3, 4, 5, 6 months, we'll have training sessions for the candidates here in Bahrain and in the region. Part of building the satellite, because it's much easier to build a satellite, to get a contract with a well-known company and get the end-to-end solution. Build the satellite, we need this data A, B, C, and D, and launch it, put it in this orbit, and we'll pay the money, we'll get the product. Yeah. And this is not what we're looking for. Part of building the satellite, it will take about 2 years. Why? Because it can be done in 6 months. Yeah. But we are going to take 2 years, because part of building the satellite is training the people. Yes. Getting their hands on. Probably the first part for the first satellite, some of the work will be done here in Bahrain, some of the work will be done abroad. Second part, maybe we'll move a little bit more closer to Bahrain, and we'll do more of the integration and testing. Some of the testing can be done here in Bahrain, some of the testing cannot be done in Bahrain.
Doing these or doing this program and is sort of saying, and we're starting from scratch. We want everybody to be trained in every single detail of doing this. We don't want to just take something ready, a product
as a black box. This is it.
Exactly.
We don't. This is what we are not looking for.
This gives the opportunity for Bahrain in the future to be a leader in this specific field as well.
In this field, or even in part of this field. For instance, one of the things that Bahrain can contribute globally, not even regionally. For instance, we are looking even for spin-offs of the starting with those group of 10 people. Maybe some of them will retain 6, 7, 5 of them. This is fine. Okay, some of them will have a spin-off. For instance, manufacturing solar panels. Yes. Okay, this can be done easily, and this can be exported to for either for space or for non-space application. Marvelous. The other thing is, for instance, Bahrain is well known for aluminum. Yes. Building this space, the CubeSat, usually CubeSats are placed in a low Earth orbit. Yes. They will operate for 2, 3, 5 years maximum, say, and then that's the end of the operational life for the spacecraft. Yes. It will keep on orbiting Earth, but due to atmospheric drag, the speed of the satellite will decrease. That will also decrease the altitude. Yes. So slowly, the spacecraft will be moving down, then hitting the atmosphere. Yeah. One of the requirements for a CubeSat is that the structure is made of an alloy of aluminum. Yeah. This alloy should have a low boiling temperature. Okay. So that when it sets the atmosphere, it would burn. Yes. So one of the other thing that we can have, since we have already got the aluminum here in Bahrain, is doing the required alloy. Yes. And and use it to manufacture these structures for the CubeSats.
Hopefully, one of these plants, exactly.
Yeah, so many. I mean, you really when you get on, you get your hands in this field. Things will open. You'll see new things that you didn't think of.
Exactly, and Bahrain is not new to innovation.
No, definitely.
In performing his duties, the space agency collaborated with several official institutions, as you mentioned before. How do you value these cooperations, and how does it contribute positively to achieving the aspired goals you have set?
This is essential. For us, this is essential. We don't want, even with our limited resources, financial or human, we don't want to start from scratch. We don't want to do the mistakes the others did. Yeah. We want to start from somewhere that minimize the cost, minimize the manpower, and focus our efforts on building, not learning so much from mistakes, but learning to build something. Yeah. And we know whatever mistakes, and we have really strong ties with the Kingdom Saudi Arabia and with the Emirates. We are doing this thing with their help.
That's amazing. Even that it's an initiative here that is located within the GCC and coming out of Bahrain is a big deal. The kingdom actually, the kingdom's accession to the UN Committee on the Peaceful Uses of Outer Space, or the COPUOS, the COPUS, contributes positively to enhancing the international cooperation in the field of space activities. Can you tell us a bit more about that?
This is essential in doing space. Your spacecraft, you've launched a spacecraft that it's orbiting the whole Earth. So basically you need to get those agreements. One of them is going through the UN with the UN Office of Outer Space Affairs. That's where the committee is under. The other thing, you need to cooperate with the, you need a license for the frequency-wise, if you have a satellite from the International Telecommunication Union, ITU. Every country with the satellite should apply to the ITU to get a license for those frequencies.
Yes.
It's a global effort. Either it's even essential, even if you don't have any space sector.
Yes.
Because part of that is the insurance. For instance, if a spacecraft decays and you got and decays and falls on your territories, you need something, an international agreement on how dealing with those situations. So it's essential, either whether you have a space industry or not.
Yeah, exactly. I mean, the UN Committee on Peaceful Uses of Outer Space was put together because of basically, as you said, there is the debris, there is the old satellites that have been there for ages now, and basically they regulate as well the traffic, and that's important if such a mission like the one that is being attempted by Bahrain is to succeed. What else can you tell us about COPUS itself? How is it an addition, the experience they have in addition to your mission?
COPUS was established back, I think, in the 1960s. Bahrain, I think, signed the agreement, and we're in the process of finalizing that. I think it was, Bahrain was number 68. Okay, so Bahrain signed that with Norway. So we're not really way far behind the rest. We're still with the bunch. It's really essential. We can use some of the experience they got, the agreements, and one of the things that from this agreement turned out that we need a national space law. And this is something on the strategic plan. But first, we need to develop the industry first, know our local problems, and then we should start on building a national space law. This is one of the things that came out from signing the memo with COPUS.
Yes, amazing. Now, Bahrain's National Space Science Agency is aware of the importance of satellites in kicking off any space program and developing aerospace technologies. Let's take a look at how the United States National Aeronautics and Space Administration, NASA, began with one simple satellite.
Liftoff, the final liftoff of Atlantis.
The NASA you know today, it was actually founded after the launch of the first scientific mission in space. After the Soviet Union successfully launched the first satellite ever to orbit the Earth, the United States was under enormous pressure to pick up the pace of its own satellite program. Built by a team of more than 100 engineers, electronics experts, and machinists working around the clock, Explorer 1 became the first American satellite to orbit the Earth just 4 months later. In reality, Explorer 1 was actually the US's second attempt to launch a satellite into space after Sputnik first took flight. Working in tandem, the Jet Propulsion Laboratory and the Army Ballistic Missile Agency had a rocket nearly ready to launch, but the Navy's Vanguard project was given the first opportunity to send their rocket into space. Vanguard made it about 2 feet off the ground before exploding on the launch pad. The Eisenhower administration, eager to ease the anxieties of a nation deep into the Cold War, gave JPL and the Army just 90 days to finish and launch Explorer 1.
Think for a minute what a different world it would be if Explorer 1 never happened. Say Vanguard successfully launched in December, the Explorer 1 may have been turned off. There may have been less pressure to create a separate space agency, so we might not have NASA. There's a lot of chance involved in all this.
Minutes click past relentlessly. The beams of powerful searchlights light up the missile. Truly the star of one of the greatest suspense dramas of our time.
5, 4, 3, 2, 1. By command. By command. Think of it. Think of it.
After Explorer 1 launched on January 31st, 1958, the space race officially began. Explorer 1 played a huge symbolic role in galvanizing America's legacy in space, but its true scientific mission was a milestone unto itself. The instruments on board made the first major scientific find of the space age, a belt of radiation around the planet linked to the very survival of life on Earth.
With Explorer 1, science moved into space, and we can finally address questions scientifically we've asked for millennia.
The launch of Explorer 1 60 years ago opened the floodgates for future scientific missions, positioning the U.S. to be a leader in space exploration. There are 18 missions observing Earth right now, while another 36 are currently exploring our solar system and beyond. To date, the United States has successfully sent a crewed mission to the Moon, dispatched spacecraft to each planetary body in our solar system, and reached interstellar space. Just this year alone, there are 8 missions launching, all made possible by the collaborative efforts of NASA, its partner agencies like NOAA, and other space agencies around the world.
Even though this started like a national activity, we've brought the world along, and it's an international activity in which humanity together transcends the boundaries and really opens up views of the world in a way we could have never imagined.
Less than a lifetime ago, humankind barely left the limits of our own atmosphere. Who then could have imagined that only 60 years later we would be touching the atmosphere of the sun, arriving at the most distant object humans have ever explored, and launching the world's most powerful telescope to get a glimpse of the first galaxies born after the Big Bang. Humanity's exploration of the universe will continue to expand, from our home planet to the far reaches of interstellar space. But wherever NASA goes, one thing is certain: it won't be boring.
And the Kingdom of Bahrain plans to establish its first CubeSat within 2 years and send it to orbit. A CubeSat is a type of miniaturized satellite for space research that has a mass of no more than 1.33 kilograms per unit. CubeSats are commonly put in orbit by deployers on the International Space Station or launched as secondary payloads on a launch vehicle. This video has been prepared by NASA about what a CubeSat is.
Satellites of the space age were small. Sputnik, for instance, weighed just 184.3 pounds. America's first satellite, Explorer 1, was even smaller, at only about 30 pounds. Over time, satellites grew to accommodate more sensors with greater capabilities, but thanks to miniaturization and new technology capabilities, small is back in vogue. NASA is one of many government agencies, universities, and commercial organizations embracing small satellite designs, from tiny CubeSats to microsatellites. A basic CubeSat has 4-inch sides and weighs just a few pounds. A CubeSat can be put into place a number of different ways. It can be a hitchhiker flying to space on board a rocket whose main purpose is to launch a full-size satellite, or it can be put into orbit from the International Space Station. Astronauts recently used this technique when they deployed the Miniature X-ray Solar Spectrometer, or MinXS, a CubeSat that studies solar flares. In 2018, NASA plans to launch the CubeSat to study solar particles, or CUSP. It will hitch a ride out of Earth orbit during an uncrewed test flight of NASA's Space Launch System. CUSP could serve as a small space weather buoy. Eric Christian is CUSP's lead scientist at NASA's Goddard Space Flight Center in Greenbelt, Maryland.
Right now, with our current fleet of large satellites, it's like we're trying to understand weather for the entire Pacific Ocean with just a handful of weather stations. We need to collect data from more locations.
For certain areas of science, having a larger number of less expensive missions will provide a powerful opportunity to really understand a given environment.
If you had, say, 20 CubeSats in different orbits, you could really start to understand the space environment in 3 dimensions.
NASA scientists are taking this approach of using a constellation of sensors to probe the details of a large area with a number of recently launched and upcoming missions. The Cyclone Global Navigation Satellite System, or CYGNSS, launched in December 2016. CYGNSS uses 8 microsatellites to measure ocean surface winds in and near the eyes of tropical cyclones, typhoons, and hurricanes to learn about their rapid intensification. These microsatellites each weigh about 65 pounds, larger than a CubeSat, but still very small compared to traditional satellite designs. Additionally, the first 4 selections from the In-Space Validation of Earth Science Technologies, or INVEST program, recently began launching. The goal of the INVEST program is to validate new technologies in space prior to use in a science mission. Raven, the first of the INVEST CubeSats, was launched in November 2016 to demonstrate a new way to measure radiation reflected by Earth. The next 3 INVEST missions to launch, HARP, IceCube, and Murata, will demonstrate technologies that may pave the way for future satellites to measure clouds and aerosols suspended in Earth's atmosphere, probe the role of icy clouds in climate change, and collect atmospheric temperature, water vapor, and cloud ice data through remote sensing, respectively. NASA's Science Mission Directorate is looking to develop scientific CubeSats that cut across all NASA science through the SMD CubeSat Initiative program. Andrea Martin, Communications Specialist for NASA's Earth Science Technology Office, believes this is just the beginning.
CubeSats could be flown in formation, known as constellations, with quick revisit times to better capture the dynamic processes of Earth. Multiple CubeSats can also take complementary measurements, unachievable by a single larger mission.
She envisions big things ahead for these little satellites.
Welcome back. Now, that was a very informative video from NASA on the CubeSat, but it differs over the years because of new technologies and more modern technologies, and also because of the things that that Earth or that the country actually need, the information that they need. So what can you tell us about CubeSat?
Well, let's talk about the fuss about CubeSat and why everybody's talking about CubeSat. The CubeSat is something like what happened in the early 80s with the personal computer. Before that, before the PC, before the personal computer, companies used to buy the computers, and it is a huge mainframe or a mini computer, and it's a more or less custom made, and you need a technical, highly technical, qualified people to operate and administrate the system. Then the PC came. It's more or less it's an open standard, and several companies can manufacture the same component, motherboards, hard disk. So now people can purchase the components themselves, put them together, making sure that each component comply with the standard or comply with the requirement for that, for instance, motherboard, and they can operate the computer. They can install the system. They can, if something wrong with one of the components of the hardware components, they can remove it themselves. They don't call maintenance people. Buy that, for instance, if the hard disk failed, buy a new hard disk, and they know that this hard disk will work fine with their PC. And plug it in, and boom, you're on
so
again.
they customize it to their personal needs.
Customize it, and it's an open standard. You have more options. You got more sources to buy the components.
Understood.
And you got several companies that they can manufacture the same component, the hard disk. You got several companies, and they are all going to work with the PC. Okay. The same thing with the memory chip. You can buy a memory chip from any manufacturer and plug it into your PC and it will work. So CubeSat, basically the idea came in about 20 years ago in 1999 to have a standard. Now this is standard can using of course with the new technology in electronics and microelectronics. You got companies, lots of startup companies that can manufacture the components. There are several subsystems in the spacecraft: power system, the electric power system, the attitude control system, the communication system. They can buy the components from different companies, plug it in, since it's standard, it will work together, assemble it, and you got a working satellite. So the CubeSat is cheaper. It's much cheaper. To get a satellite, it's usually a customizable satellite that the manufacturer will customize it for the client.
With standard options.
There's a standard option. There is the bus, and then the payload depends on the option. Whether you want, for instance, for remote sensing, then you'll have cameras, and you have to get the orbit right. If you want for communication, for instance, the way people receive TV broadcasting, you got to have a geostationary satellite with lots of transponders. That's the payload to receive the signal from the station and broadcast it back to the area of interest. With the CubeSat, it's very small. It's open standard, so the components is much cheaper than, instead of talking about $10 million, 20, the real satellite costs maybe 100 million, 200 million. Some of them goes beyond even 500 million. You can build your own satellite with maybe $100,000. This is a change in space terms.
Of course.
Wow. So this is why we started with a CubeSat. The payload we are looking for is not, as I said, it's not going to produce real data that will be beneficiary for our for Bahrain. But the real benefit, we're talking about getting the people the skills. So when you start with something, if you want to teach your kid math, for instance, you don't start with integration and calculus. You start with addition and subtraction. And then you move on to multiplication and division. This is what we are doing. We are taking a simple system. This is not really going to be a wow system, a high-end system. It's going to be something, an educational tool rather than a real space product. The real space product, hopefully, will be our next step. This is one thing in parallel. Maybe I would mention something else. This is building a satellite, and the way you understand how to design a satellite and all the technical details within the satellite. This is one thing. The other thing that's going to be adjacent with building the satellite is building a ground station. With the satellite, this is another skill that we need people to acquire. Building a ground station, this is what we call mission operations. You have to know how your satellite, the orbit of the satellite, when are you going to be getting in contact with the satellite, the contact window. You have to calculate all those stuff. And then the direction that the satellite is going to be, you have to point your antenna to the satellite and then follow it. To get the communication, you have to communicate saying, okay, I'm in contact with you. Now you can transmit your data. The satellite will transmit and you will receive, and then that's it. If you want to, for instance, take an image of some certain location, you have to know again exactly where the satellite, when it's going to go orbit, will have a coverage on that area. When you, at that time, where it's the location of the satellite. Okay. For instance, if this is Bahrain and the spacecraft is going slightly to the east of Bahrain, this is what one of the most important skills. Then you have to program the spacecraft to look not directly downward, but slightly to the left and slightly ahead. As the spacecraft, the satellite is moving in its orbit, Bahrain is moving slightly down, the satellite should turn slowly and keep looking at Bahrain. Okay, until it's out of view. Maybe on the next orbit will transmit, or maybe during the same orbit there is some processing unit that will take the image, process it slightly on board, and then transmit it through the, for instance, what we call the S-band. This is the high rate telecommunication package. There is several packages. This is one thing. The next pass, the satellite may be coming over Bahrain to the west. So in that case, again, it should turn to the right to view Bahrain. So this is the one of the important skill that those Bahrain space team, some of the members of the team should acquire.
It's actually very important to mention at this point that the reason we're explaining it this way is because the whole event of or the mission is very planned out to the smallest detail kind of thing. So nothing just happens with an open link or, for instance, open questions. No, everything is planned out from A to Z, and that's what you're.
And we are, yeah, exactly. And we are working the details, even for the payload. For the payload, we are looking essentially the primary payload is the camera, basically acquiring the skills for remote sensing.
Yeah.
For telecommunication. The other primary payload is transponder. Transponder is the telecommunication. It's transceiver. It's a transmitter and a receiver.
Yeah.
It would receive the signal with a given frequency, change the frequency slightly for not to get the interference, and then transmit it back. And this is essential in telecommunication.
Yes.
So the transponder package on the CubeSat, the plan is for people to get acquire the skill for telecommunication.
Yes.
We got a secondary package, but that depends. Now we have to do really the details. Let's see, do we have enough power on the satellite to operate all these equipment?
Yes.
If not, if it's essential, then sometimes we need to switch off one of the instrument and switch the other one on.
Yes.
For in the second case, no, the priority gonna be for the second payload, for the second instrument, so we have to switch off the first one and switch on the second one. These are the skills that we need.
Yes. Doctor, before we move on in this, I mean, you're an academic yourself and you're also a man of science. The fact is the fact that that Bahrain is starting this way, it's taking 2 years, but progress usually comes faster because we have knowledge. Do you agree from that point of view that this first step is huge because it will give us the information we need to progress in this field?
Definitely. This is a huge, this is the starting point for us. We are starting with those 10 people. We don't want to start too big, that we can have so many people to handle, and we don't want too few people that we don't have the manpower. 10, I mean, we went through interviews, we met with several companies dealing with the small satellite and the CubeSat, and most of them, we didn't, the number of 10, we just didn't come up from out of nowhere.
Yeah.
It's even the specialization for the candidates. It's based on international standards. We talked to companies, they gave us their advice on how to start, something like that. So basically, yes, this is a big job. Taking 10 is most 10 to 15 people. This is what we've been told is the optimum number of staff you need to start something like this.
Hopefully, inshallah. Now, what are the procedures that are going to be taken by the National Space Science Agency to spread the awareness of its role and activities on the local level?
Well, we got contact with the Ministry of Education, and they gave us the content of the science and geography and related subject. The content deals with the space and astronomy, and I think they have lots of content for these for the schools, and even at the university. The NSSA is promoting teaching, having courses in space science, aeronautics, control systems. These the essential skills that are required to build such a team.
Yeah.
We don't have a space. Worldwide, I think they just started a space program on the bachelor level. Yeah. Traditionally, people would come from engineering or IT or science, and they would do science as a master or a PhD.
Yes.
But I think here in Bahrain, even in school, they will start exposing to science and space science.
Yes.
The universities, at least I'm talking about the University of Bahrain, we already have a couple of courses in astronomy and space, and in engineering they got the control systems. They got, for instance, one of the things we need is GIS, Geographical Information System.
Yeah.
This is when you get the data back from the satellite, how to use it.
Yeah. All right. So this also opens the opportunity that maybe, I mean, our history, as in the Arabic and the Islamic history, has a lot of astronomy information in it. So it's been actually something that's over generations within our culture itself. And since the launch of the initiative last month, the National Space Science Agency received around 2,173 applications to join the Bahrain space team. Now, as you said, your team will actually be consistent from 10 to 15. So you guys have a lot of work to do when it comes to the interviews, to the filtering and everything. But how do you value that there's so much interest from Bahraini people, young and old and everybody, to be part of a leading project like this?
I think this is very expected.
Yeah.
We had application from kids in school still. We had application from people that are older than me. Okay, I think everybody is interested in getting in that field, and it's not a surprise.
Yeah,
it was very expected from Bahrain that Bahrainis that they want to join something like that, and even for me as a kid, I mean, looking at stars, looking space is really inspiring.
Yes,
and I think it's going to be a hard task to get those 10 people out of those 2,000 people. Not because we don't have enough people, but we have. Bahrain is known for being so educated and so. But now getting those 10 people out of those numbers, this is the difficult thing.
Yes.
You got so many options.
Yeah, yeah, and it's very also important to mention that when something is done in Bahrain, everybody shines. So when someone is successful in Bahrain because of how the people are together and how the institutions work together, if you do something positive, then you will shine, you will be in the spotlight. And you are in the spotlight, your program is in the spotlight right now on this point itself. What are the plans and the training programs that have been prepared by the NSSA to equip the space team members with the required skills that you mentioned and the knowledge that they need in order to make this a successful mission?
Yeah, of course. Now, getting the space team, by default, we need people with different backgrounds. We need people in telecommunication, people with engineering skill, mechanical or electrical, electronic. We need people in science, so they have diverse backgrounds. One of the first courses is getting acquainted with the space terms. When we talk about a satellite, when we talk about the subsystems, they should have the same background. So when the next step, when we get really technical, they would have the vocabulary for that. And when we talk about, for instance, reaction wheel. Okay, nobody knows what's the reaction wheel, and this is expected. But this is an essential part. So basically, the first part going to be locally here, getting acquainted with those terms, getting acquainted with those subsystems, not really knowing exactly how they work, but at least they know what they are doing. The next step, maybe it's going to be here, maybe it's going to be somewhere in the region, is getting them more advanced training. And maybe more, if we reach a step, depends on, still there are lots of unknowns. This is our first time. Okay. Then maybe getting specialized training. We'll choose 3 or 4 depending on the background and depending on how the skills they will show, how their interest, their passion, doing the electronics part. 3 or 4 doing the programming part. 3 or 4 doing the telemetry and communication. And this is something that we are really working on at this moment.
The training must be massive. I mean, it is also knowledge oriented, but also physically they will be challenged as well. Is that right?
Yeah, definitely. This is definitely. That's why we're looking for young, open-minded, creative people. They're going to deal with something they have no experience with. This is definitely, they will face problems for the first time. And how to handle that, that's up to them. That's their skill. That's their touch.
It will be inshallah success. What are the expected challenges that they will face maybe, or that might face the NSSA projects that are upcoming?
It's like a startup. We're just starting. It's it's charting the unknown for us, at least for us. It's charting something unknown, getting the right people, getting this is why we need our brothers in Kingdom of Saudi Arabia and the United Arab Emirates. They are steps ahead of us. Are we taking the right decisions? Are we employing the right people? Are we buying the right hardware? Are we walking on the right track? Or there is a faster track that we can take with our resources, human, whatever. This is something we're really working on.
A program like this that is being basically done from the beginning, from raw knowledge, raw information, raw material, means that there will be coming mistakes, and the point is to learn from them and to improve, and not just to basically be hindered by them. So what can you tell us about the progression? What comes after this mission is successful?
Hopefully, building a satellite, they will know how to build a satellite, how to build a ground station, a simple ground station, how to operate the satellite. The next step is building a larger satellite. I won't say much larger, but a larger satellite. A CubeSat, as you said, is about no more than 1.3 kilogram. This is what we call 1U. 1U is 10 centimeter by 10 centimeter by 10 centimeter.
Oh, okay.
So it's about one.
Small.
Yeah. It's about 1 liter in volume, and the mass is about 1 kilogram, slightly less or more depending on the system itself. What we are planning to do is what we call 3 unit. So basically, plug in 3 of those together in one system. It's going to be 10 centimeter by 10 centimeter by 30 centimeter.
Okay.
This is done. Going to be the mass will be around 3 kilogram to 4 kilogram. This is what we call nano satellite. Our next step is building a micro satellite. Something 50 kilogram, 100 kilogram, something like that. Things will evolve. Things will be clearer for us. What we are doing now is going and meet with the stakeholder, different ministries, different directors in ministry, and getting their needs. This is the national needs, national requirements. This is really what would define our next mission. Exactly our next mission. What information do the different ministries need in their work? And depending on that, we need to define our payload. For instance, is air pollution a problem? If that's a problem, then we need something to measure the air quality. If it's not a problem, then we don't waste our effort, our money on that thing. In remote sensing, one of the tools in remote sensing is taking the image in infrared. Do we have people that require remote sensing? Most likely, yes. Okay. So if this is a need, then maybe we need a satellite with more bands to get in the visible, and maybe 2 or 3 bands in the infrared. This is what we are trying to do. This is what we are trying to find out. This is something even the other side. The client, the people that are going to use the data, they don't know that this is possible. Okay. One of the things that we are trying to do is awareness campaigns. Okay. We're trying to get people who've been using these things coming and explaining to the government entities, even to the public, what is possible to be done with the space data. This can be done, this can be done, this can be done. In Bahrain, we have this problem, so this thing is really suitable for us and we can use it. This is not a real problem. So, and this is the way we define our next step. We need a larger satellite. There are lots of applications. Exactly what application do we need? That
will be targeted later or seen later. The web page that has been set up by the NSSA is very informative, and people can basically see some information also from the media and from us as well. We've come almost to the end of our show. I would just like to ask you if there's anything that you would like to conclude with, and maybe give us a little bit more details on how this program will benefit the 2030 vision.
Talking about the media and informative, we're also working on some movies, short movies, and there is a booklet hopefully coming within a couple of months explaining why do we need space, what benefits we can get from space. For 2030 sustainability, this is basically space science is a tool, and it's up to you how to use it. And it's a very fertile, you got lots of variation in that. You can do lots and lots and lots of things. There is no limit. It's basically, this is the second part or the third part of what we are trying to do is how to handle the data. You build your satellite, you got the payload, you observe the Earth or whatever you want, you downloaded the data. What's next? Okay, this is our we are starting that step, getting qualifying people in handling data. Okay, either as an image, doing planning, doing the maps, or as a remote sensing, looking at different things. For instance, you can look at the plants, the crops' health from satellites, whether it's going okay or not. You can also know the crops types from the satellites, just looking at the infrared images and you can see this is corn, this is wheat, this is, and so on.
Yes.
Yeah.
Because of the difference in the molecular level.
Molecular level and different reflection of light, how they will reflect the infrared. Basically, one of the most important tool in remote sensing is using the infrared bands.
Okay.
Okay. And remote sensing is not my field at all, but we need somebody who can do that.
Yeah.
Yeah.
Yeah. Understood.
Yeah.
All right. Thank you very much, Dr. Mohammed Al-Uthman, for being with us today. This topic is massive, it is huge, and we cannot finish it in one subject, but we also want to give the chance to basically for you guys to do your steps and choose the team and everything. So I'm sure we're going to have another episode, hopefully, on the progress of the mission itself. We would also like to thank you for watching and see you next week in another episode of Inside Edition.